Good morning, all you positive people. Um, in the notes, I titled this Super Simplifications. You can call it whatever you want, but the main thing here is we're just going to use algebra skills to simplify expressions. And the purpose is because later down the road, the expressions that we're going to be simplifying, we're going to get to using some calculus techniques. And then once we get to that point, the rest of the question is really just going to be algebra. So we're just going to focus on an algebra skill that's going to come up later. So, um, some rules to make our simplified answers more uniform and easier to work with. Um, you'll see in a second, but context is really the most important thing. In general, it's good to have a common denominator, so a single fraction, combine like terms when possible, and have forms of have your exponent as just ax to the r rather than having like the square root symbol. So like right here, rewrite that as just x to the 2/5 rather than the fifth root of x squared. But sometimes you write it like that, and that's okay. So negative exponents right here, we can rewrite as positive exponents like that. A fraction and a fraction, do the keep change flip. Here we have two fractions, so we can combine them. 2x plus 3x is just 5x, so we can combine those. But really, context is the most important thing. Depending on what the question's asking us for is what form is going to be best used. What's important isn't recognizing what looks the best, it's just being able to go between two different forms of the same expression. This first example, copy it down. If you want to slow me down or pause it, feel free. I have a negative exponent right here, so I'm just going to rewrite this as 1 over x to the positive 3 minus x squared. So now I have all positive exponents, which might be what you want. And then if you notice, we have two fractions here, so we can get a common denominator. I can multiply this one by x cubed over x cubed. This will give me that common denominator that I wanted. So now x cubed is my denominator. And my numerator is going to be 1 minus x squared times x cubed is x to the 5th. So that's fine. And we can get a nice simplified version. Another way of doing the same thing, this is steady, show me this one, is take this x to the negative third minus x squared. And recognizing that the x to the negative 3 is going to be the denominator, right off the bat here, I can just multiply the top and bottom by x cubed. Just know that this is like over 1. So then what this would give me is the bottom is just going to be x cubed. X cubed times x to the negative 3 would be x to the 0. And x to the 0 is really just 1. And x cubed times x squared is just x to the 5th. So you get the same answer as we did over here. So the same idea, but just thinking about it differently. Again, just kind of getting comfortable with the algebra. Here are some radical symbols. The square root of x is really just x to the 1/2, so just recognizing that. X squared, the cube root of that is going to be x to the 2/3. So in general, if you have the 8th root of x to the b, the power is b, the root is the denominator, so power, I've heard teachers say that. Power over, is it that root or is it that root? I don't know. I'll look into it. And that's fine there. If you left it like that, that's fine. Another common thing, you probably heard this in calculus, is rationalize the denominator. I don't want to have a 2/3 in my exponent. One way to get rid of that is multiply the top and bottom by x to the 1/3. If you don't do this, that's fine, but just kind of like observe the algebra here. Why did I pick that? Well, because when I multiply these two things together, you add the exponents, and x to the 2/3 times x to the 1/3 is x to the 3/3. And x to the 3/3 is really just x to the 1st, or x. And then when you multiply it on top, you got to do a half plus a third. So that's going to be x to the, what's that become? That's 1/2 plus 1/3. Let's see, that's going to be 3/6 plus 2/3, which is 5/6, plus 2/6, which is going to be 5/6. Minus, Oh boy, not good timing for that. Let me exit out and go back in. Yeah, here we go. So we have minus 3x, and then I got to do the 3 plus 1/3. 3 plus 1/3 is the same thing as 9/3 plus 1/3, which is 10/3. And then 5 plus 1/3, 5 plus 1/3 is the same thing as 15/3 plus 1/3, which is 16/3. And what I'm doing now is just working with fractions. And again, these are just skills that like we're gonna need, and you're gonna get more practice as we go on. So, leave your answer like this. That's fine. If I want to rationalize the denominator, maybe in pre-calc, that's an answer that you're gonna want. Again, I don't care if you know which one's the one the right one, because there's no right or wrong answer. I just want you to be able to understand the algebra behind it. All right. Copy down example 3. Now I want to simplify it. I see this y to the 12th on the bottom, and I see some y's on the top. So I'm just going to factor out the GCF on the top. I can take out a 5 for sure. They both have x's. The lowest exponent between the x's is 3, so I can take out 3 of them. Oh, and they also have y's. So between the 8 and 7, the smallest exponent is 7, so I can take out 7 of them. So in this first term here, the 5's gone, the x to the third's gone, but there's still 1 y left over. On the second term, I took a factor of 5 out, so there's going to be a factor of 2 there. I took out 3 of the x factors, so there's one x factor. There's 1 x left, and then I took all 7 factors of the y out, so that's gone, and I'm left with y to the 12th. Now that that's factored out, 7 of these y's can kill off 7 of those y's, so I'm going to have 5 left over. And then that's the answer. We'll just leave it as 5x cubed. I'm going to switch the x and the y just so it's in alphabetical order. It doesn't matter. Over y to the 5th. If you want to distribute the 5x cubed back in, that's fine. I don't really care. I'm just going to leave it like that. Okay. So, again, algebra, simplifying. Now, this one looks like it's difficult for no reason, but this one actually is the most reason. This is like one of the more important ones that we're going to do, because when I said we're going to do this calculus stuff to a function and end up with something that we just have to simplify, this is the something that we have to simplify. And it's pretty abstract, and I'm going to give you guys some practice with it in class for sure, but I want to factor out something out of the numerator, and a couple things I can factor out. First, I see 15x squared and 10x cubed, so I can factor out a 5x squared out of that, 2 being the smallest exponent, and 5 being the greatest common factor of 15 and 10. Not only that, but both terms have a 4x plus 5. So I can factor out a 4x plus 5, and I'm always going to take out the smallest exponent. So between 1/2 and negative 1/2, the smallest exponent is negative 1/2. Okay. Once I do that, then I have kind of like what's left over. So what did I factor out? Well, I took a factor of 5 out of the 15, so it's going to be a 3. I took x squared already out, so there's no x squared left over. Now I have a 4x plus 5 left over. What's the exponent here? If I were to multiply this back in, the exponent here, when added to negative 1/2, needs to give me positive 1/2. And so negative 1/2 plus whatever that number is needs to give me the positive 1/2 when I multiply it back in. That number is going to be 1. So this is really just going to be to the first power. And it's not by chance it's going to be to the first power. It's going to be like that every time. There's a reason why, and once we get into the calculus stuff, you'll see. Moving on. So that's like the first chunk. Now the second chunk, we took out a 5x squared, so there's going to be a 2x left over. And the 4x plus 5 to the negative 1/2, we took that entire thing out, so there's nothing left to take out. And I'm left with 4x plus 5. Now right here we have a negative exponent that's factored out. So just remember, if you have a negative exponent, so if I have x to the negative m, that's the same thing as 1 over, excuse me, a to the negative m, that's the same thing as 1 over a to the positive m. So I can take a negative exponent, cross the line, the fraction line, change the sign. So I can take that green piece there and bring it to the bottom. And that negative 1/2 will become positive 1/2. So we still have the 5x squared. On the bottom, I have this 4x plus 5. But I also have this green, this 4x plus 5. If I bring it to the bottom, that negative 1/2 will become positive 1/2. And then this this black stuff here, I can just distribute out. So 3 times 4x is 12x. 3 times 5 is 15 minus 2x. Now, these both have 4x plus 5 as a base, so I can combine those. 4x plus 5 to the 1/2 times another 4x plus 5 to the 1, just add the exponents. And you get 4x plus 5 to the 1/2 plus 1 is 3/2. And on the top here, I'm going to do it all in black now. We have like terms. 12x minus 2x is 10x. And then we have that 5, yes, that's correct. And then we have this 5x squared. From here, I'm good if you circled it. You can multiply the 5x if you want in. Doesn't matter to me. So, put a box around it, go to the next question, or distribute it. You'll get 50x cubed plus 75x squared over 4x plus 5 to the 3/2. This is a question in a book. You could look to the back of the book and see how the people who wrote the book answer this question. But again, this certainly is a better looking version of this right here. So I think we can agree on that. And again, just the algebra skills that we're working on here. Here's another one. You're going to want to copy it down. Pause the video, copy it down, and then here we go. Again, this isn't difficult for the sake of being difficult. This is something that we're going to run into and need to be able to simplify. So there's kind of like two pieces here, separated by this minus sign. So the first piece, I'm just going to, real quick, I see the 7 and a 15x squared. I can just multiply those things together real easily. 70, 80, 90, I think it's 105. If I'm not mistaken. Yep. So that's going to be 105x squared. I'm going to leave the 4x minus 7 to the 5th alone for a second. And the 5x cubed plus 3 to the 6 alone. Minus, the 4 times 4 is 16, so I can do that. And then leave the 5x cubed plus 3 alone to the 7th. And the 4x minus 7 to the 4th alone. Now on the bottom, I have something to the 5th power raised to the 2nd power. So in general, if I have a to the m to the nth power, you just multiply the powers, m times n. So just multiply 5 times 2, and that's going to give me 10. Now, we're going to do some factoring here. Both pieces have a 4x minus 7, so the lowest power between 4 and 5 is 4. So I'm going to take out a 4x minus 7 and take out that lowest exponent. That's the greatest common factor they have in common. And then there's also a 5x cubed plus 3 in both cases. So the 6 is the smaller one. So I can take a 5x cubed plus 3 to the 6 out. And then what's left over? Well, in the first chunk, the 105x squared, I took out 4 of these 4x minus 7 factors, so there's 1 left over. Again, that 1 is not a coincidence. It's going to be like that every time for reasons to be decided later. This 5x cubed plus 3 to the 6, I took out all 6 of those factors, so that's gone. You could think of it as a 1 being there, but we're not going to do that. And then I have a 16. And then 5x cubed plus 3 to the 7th. I've only taken out 6 factors, so there's one more of those left over. And then the 4x minus 7 to the 4th. All 4 of those factors are taken out, so that's gone. And this is all divided by 4x minus 7 to the 10th. 4 of these factors will kill off 4 of those factors, so I'm left with 6. And then from here, 5x cubed plus 3 to the 6 is just going to be chilling. And we're just going to clean up this parenthesis right here. So distribute 105 times 4 is 420, I think. X cubed. 105 times 7 is going to be 735 x squared. Minus 16x times 5 is going to be negative, I think, 80x cubed. And then negative 16 times 3 is going to be negative 48. All over 4x minus 7 to the 6. Let me just check my answer key. Yes, yes, yes. Okay, my mental math isn't so bad. And then I have 420 x cubes minus 80 x cubes, which is going to be 340 x cubes. Minus 735 x squared minus 48. The 5x cubed plus 3 to the 6 is still there. And the 4x minus 7 to the 6 is there. And that's it. All right, the bell is about to ring, and I think a class is coming in, so I'm going to stop the video now and make a part 2. Oh, there it goes.